Welcome to the how-to video Parallax P-Basic and the Board of Education. The first thing we need to do is go to the Parallax website at this location and download our P-Basic, and they have versions for Windows, Mac, and Chromebook. Here I am in Canvas, and I'm at Module 6, where it's our first Parallax stamp, and we're going to open up our basic stamp software. And we're going to download for Windows, Chrome, and down here a little lower we have Mac. So go ahead and save it. And when it gets loaded, go ahead and download it. We may need to use our Parallax drivers, and let's go ahead and just download the USB drivers because we're going to utilize an adapter. So here I'm showing our stamp Board of Education and the connections. Here we need a USB to RS-232 adapter, which should come in the package. And here's our 9-volt battery, or we'll be using a power supply plugged in. I think we're going to use a 9-volt battery. And here's our stamp microcontroller. And there's our switch. So position 0 is off. 1 is the stamp is on the microcontroller. And 2 is the stamp plus our servo connections right up here will be turned on. And let's see here. At the top we have our VDD, which is plus 5 volts. Our VSS, which is ground. And our VN, which is based on our 9-volt battery, is right in the center. Here I'm showing the proto board on our Board of Education, and this row right here is our microcontroller pins, P0 through P15, which are connected directly to the microcontroller. This center trough here is no connection between side to side. So that's where we're going to place the IC, and it's going to straddle that center trough. Here we have 4 or 5 horizontal, and these are all connected straight across. There is no connection to this other side, so all of these horizontal pieces are connected straight across. There's no interconnection between the two, and there is no interconnection between our microcontroller pins and our board, so these are independent. Okay, the next thing we need to do is once we download our zip file from Parallax, go ahead and unzip it and run the installation package, and we'll end up with an icon for the basic stamp editor. Then we're going to go to Canvas, and we're going to put the files onto the desktop or somewhere where you can find them. Once they're unzipped, then we'll have all our files located here. So if we put the locations of the file headers, we can go in and open it from the file itself, or you could go in and do the basic stamp. So the first program we're going to run is Hello World. Okay, so once we have it all set up, we're going to go to the arrow here, the run arrow, run it, and the stamp has to be on. So go ahead and put it in position 1. Green light should be on. Go ahead and hit run again, and it finds it, and when it prints up Hello World into our serial display, it is working. That means we have good connection and it's programming. Okay, here we have project 1A, and here I'm showing a LED. And here's a symbol for an LED with the arrows coming out showing that it's flashing light. And you see the bar here? That's equivalent to the flat spot or the shorter leg on the LED. I wouldn't trust a shorter leg since students have touched these things before, so you may not be able to tell which is which, but you could always go by the flat. Okay? And my rule is, if the arrow is pointing towards ground and you have positive on the other side, it should light. Any other way, it won't light. Okay, here's our schematic. VDD means positive 5 volts. Here's our 470 ohm resistor in order to reduce current so that we could get the adequate light. And there's our LED, and VSS is ground. So we're going to go from VDD over to our LED, and we're going to put the flat towards the VSS and ground. So here's a schematic of our electron flow. So we have electrons flowing out of the negative terminal, going through our LED, back through our resistor, which reduces the current, back to our positive terminal. Okay, and here we have the flat, and it's pointed towards ground. Here's our actual circuit. I'm coming out of VDD. Here's our LED, yellow, violet, brown. All right, so we have 4, 7, and 1 0, 470 ohms. Gold is 5%, and we have it tied into the same bus here, going through our LED, and our flat, our ground, is going back to VSS, and it's on. Okay, here it's project 1D, and I'm not going to wire this up because we have ground to ground. There's no positive connection, no current flow, so our LED is not going to light. Okay, here we are at project 2, and what we're going to do is we're going to take the power and we're going to provide it from our microcontroller. So we're going to come out of pin 14, and this device and all microcontrollers can provide a plus and a ground. All right, so here's VSS as ground. This will not light. Okay, because it's hooked ground to ground, just like we showed at the last project. Here we could provide power, VDD, which is going to go through our current limiting resistor, and our ground will be tied to our ground of our microcontroller. Now we could turn our LED on and off with our microcontroller. So in order to use the microcontroller, we have to connect our resistor to our pin, but we need to use a program. This program is in PBasic. It's one that operates our stamp. And anytime you see a half of a quote, that is a comment, okay, and it doesn't do anything unless it's these two that have the braces around it. So here we're declaring it's a BS2 stamp. There's several different models of stamps. And we're going to use our PBasic version 2.5, which gives us some more advanced programming features. Okay, so here's our program. Blue means that it's a recognized command for our stamp. So a do and a loop means it's going to continuously rotate in here. So do and loop is going to continuously go through this program step by step. Microcontrollers operate one step at a time. And here we're going to step through this program continuously. So when we have high 14, pin 14 is going to be 5 volts or high. Okay, so our LED will light. When it's low, 14, we're going to provide a ground, so it's going to be off. Here's pause, which is a time delay, and we go by 1/1000th of a second. So 500 divided by 1,000 would be a half second. So our LED is going to flash continuously, a half second on, half second off. Okay, here we're back to our basic stamp programming. And we're going to go back to our folder where we had our stamp programs here. And I am going to go to File, Open, go back to our folder, and I'm going to use LED on and off. And if we want to clear the top, we go ahead and close. So here we have our LED on off, and let's go ahead and run it. And it's green, so it's successful. Okay, here we have our LED flashing, and it's flashing half second on, half second off. Here we are at project 3, And what we're going to do is we're going to add another LED, and we're going to put one in our 15 and one LED in pin 14. Okay, and here's our program. Again, we have our beginning information, our do loop, which means it's going to be continuous. So we're going to turn 15 on, which is the red, and we're going to keep the green LED 14 off. We're going to wait half a second. Then we're going to turn 15 off, 14 on, delay half a second. Then we're going to turn them both off, delay half second, then start again. Okay, one thing we encourage is experimentation. You can't hurt these things. So let's go ahead, and what we're going to do is we're going to make it count. So we're only going to do a certain amount. So what we're going to do is we're going to add a for next loop. And we're going to use a variable called counter, which we need to define as a variable byte, which is 8 bits. So what we're going to do is we're going to count from 0 to 10 and stop. So we're going to turn on 14. We're going to pause 500. We're going to turn 14 off with a low, and we're going to pause 500. And we're going to do this 10 times. Okay, here our debug. This is going to put up our serial window, and display our count. Okay, so go ahead and feel free to run this program or go back through the other programs and experiment. So what we can do is we could go ahead and change our times. We could go ahead and add our LED 15 and make it count the same, or split them up and have them run at different times. So there's a lot we could do with these microcontrollers. Just feel free to go ahead and experiment.